Hi everyone, so we're starting a new topic with this lesson. We're looking at the topic called exponential and logarithmic functions. And with our very first lesson, we're going to be looking at index laws. Now hopefully this is a bit of a refresher for you guys from year 10. And we'll just refresh our memory with what the index laws are and how we can apply them. You may see some more difficult examples in compared to previous years, but let's get started. So, just for some key terms, the expression a to the power of n is called a power, where a is a non-zero number called the base, and n is a number called the exponent or index. And if we were talking about the plural of index, we call them indices. So let's just refresh our memory of what index laws that we know. Maybe the last few you might not have seen before, but you should be familiar with at least most of these. So I'll just keep that frame right there just for you to look at, and we're going to apply some of the skills. So let's look at particularly index law 1. So if we're going to look at the very far left example, we've got 2 to the power of 3 times 2 to the power of 12. These both have the same base, and so we're just going to add the two powers. Okay, so 2 to the power of 3 plus 12 gives us 2 to the power of 15, in which case we could work that out. But we're just going to leave it like that. Could also do the same with our x's and y's. Make sure we group them first. Okay, so x to the power of 2 times x to the power of 4, and y to the power of 3, and y to the power of 1. This will give us a total of x to the power of 6, y to the power of 4. Can also do the same thing here. So this is just x plus 2, which gives us 2x plus 2. It's always smart to just put everything in order. So for this one here, we're going to put all our numbers first, all our a's second, and all our b's third. So 3 times 4 is just 12. And with our a's, we have 2 plus 3. And with our b's, we have 3 plus 3. So our final answer should be 12, a to the 5, b to the 6. Again, putting our numbers first, 4 times 12. And here we have a negative power, so negative 6 plus 4. There's a bit of a typo there. That should be, and I'll hopefully be able to annotate this. This should be 6 plus 4, negative 6 plus 4. In which case that should give us negative 6 plus 4 is negative 2. Okay, so just be wary of little mistakes that we can make here and there. Okay, cool. And then because we have a negative power, we're going to want to have that, again, that's another mistake. That should be to the power of 2. So the second we have a negative power, we're going to bring that to the bottom with the positive power. Okay, so just to sort of refresh your memory, a to the power of negative n is equal to 1 over a to the n. Okay, and this, if we go back, is the same as index law 7. So we've just thrown that one in there, bit of a spanner in the works, but it's very possible that we can combine all index laws. And you'll see as this lesson goes on, we're going to combine multiple index laws. So here we clearly have some division to deal with. As you can see here, but as you can see here, we're going to combine multiplication and division. So this will probably be index law 1 and 2. And let's see how we go. Let's start off with the first one. So x to the 4, y to the 3, all divided by x squared and y squared. So let's just group our x's. So x 4 take away 2. And x and y 3 take away 2. As you'll notice, this is index law 2. So whenever you divide two terms with the same base, you subtract their powers. And this will give us x squared and y to the 1 which we can just write as y. As you'll see here as well, okay, we're going to be doing index law 1 and 2 together. So let's just deal with the top part first. So let's just say, all right, b to the 4x plus 1 all over b to the 2x. Let's simplify the top part, which gives us 5x plus 1, and then now we can do our subtractions. So we're going to have 5x plus 1 take away 2x, which should give us 3x plus 1. Here we've got, some multiplication in the top and bottom. So let's just simultaneously figure out the top and figure out the bottom. You can do this in as many steps as you like, or you can do it all in one hit, whatever you feel more comfortable with. So you don't necessarily need 4 or 5 lines of working out, but this is just so you can be seeing what's happening at each move. So in the top part here, we've got x to the 3a take away a. Okay, so actually straight away what they've done in this example is they've just, rather than doing the multiplication, because we can't simplify top and bottom, sorry, that was my mistake. We don't have common bases, so these two are different, so we can't do any of the multiplication just yet. So what we're going to do is work out this first, which gives us here. So 3a take away negative a, and negative 2b take away b. So that's how we got that straight away with the multiplication symbol in between. Simplify that and we get 4a and negative 3b. Now with this one here, we've got a negative power. We don't like having a negative power, so we're going to bring it underneath with a positive power. Okay, now we'll definitely use index law 1 because we have common a's, common b's, and common numbers. So 16 and 4 goes first. The a's added together, 5 plus 4. The b's added together, 1 plus 3. And at the bottom, 8ab. So let's simplify the top part, which gives us 64, a9, b4, all over 8ab. Okay, and so one thing we can do now is that we have a few options. So one way to do this would be to just divide everything. So 64 divided by 8 is 8. A9 divided by A is just A8. And B4 divided by B is just B3. So that's one way. Another way you could have done this, I'm just going to separate this here, is you could have just said, okay, how many times does 8 fit into 8? Once. 8 fit into 64, 8 times. Then we could just cross out 1a on the top, 1a on the bottom, 1b on the top, and 1b on the bottom. And that would give us straight away, that would give us 8, a, 8, b, 3. So you can do either way. Okay, so I'd just like to show you multiple ways to simplify these expressions. Okay, now this is moving on to index law 3. So whenever we raise a power to another power, we're multiplying the indices. So this would give us a15. Here, b6 and times b negative 2. Okay, because again, we're multiplying these two numbers. And then we can simplify this using index law 1, which would give us b negative 12. I think that might be wrong. So that is definitely incorrect. That should be 6 minus 2, which gives us b to the 4. So make sure you're looking out for common mistakes. Now, if we talk about reciprocal, the reciprocal of a fraction is simply flipping it upside down, 3 over 2. For fractions with the index of negative 1, Essentially, what that means is we're just flipping the fraction. Okay, so fractions with other negative indices take the reciprocal and then raise it to the positive power. So here, we're going to flip the 5 over 6 and make it 6 over 5 and raise all of that to the power of 2. Okay, in which case you could work that out, and that would be 36 over 25. So let's try and evaluate some of these. So we have 8 to the power of negative 2. So straight away we know that that's going to be 1 over 8 to the power of 2. Okay, and straight away we can work out that 8 to the power of 2 is 64. Here, same thing as the example before, we're going to flip the fraction 2 over 1 and then raise it to the positive power. That's going to allow us to have, well, 2 over 1 is just 2, so 2 to the power of 4, and that gives us 16. When it says evaluate, it means give us that number that it could most simplified be. So I don't want to leave it like this. If I know what 2 to the power of 4 is, I'm just going to give the actual number. This is what it means to evaluate. For this third example here, we have a couple of different techniques that we can do. We can just do the same thing we did before, flip it and raise it to the positive power. But let's try something else first. Let's raise each number in that fraction to the power of negative 3. So 3 to the negative 3 over 4 to the negative 3. And that basically is the same thing as saying 1 over 3 to the power of negative 3 divided by 1 over 4 to the power of positive 3, sorry. And whenever you're dividing two fractions, you know now to times and flip the second one, in which case you'll get 4 to the power of 3 over 3 to the power of 3, which gives us 64 over 27. I personally don't like this way. I think it takes way too long, and I guess this is why we've shown you, because this technique that we've just learnt in the previous example is much easier. So, best thing to do is flip the fraction and raise to the positive power. And then from there, raise each number to the power of 3, and then from there work it out. This is, in my opinion, much, much easier. Okay, nearly done. 2 more examples for this lesson. So, there's a few index laws going on here. We've got negative indices, we've got raising powers to powers, and we've got simplifying using index law 1. So the first thing we're going to do here is we're going to try and get rid of these brackets. So I'm going to multiply this 3 here with each different section. So it should be 2 to the 3, which is eventually going to become 8, a to the 6, and b to the power of 9. Same thing here. So this negative 2 here goes to each of these. And we've got 3 to the negative 2, a to the negative 2, and b to the negative 8. Now we're going to bring all the numbers first, the a's second, and the b's third. Okay, we can see here we've already worked this one out. This one's gone here, and so on. Okay, so simplifying, I'm going to turn this one here into a fraction. Sorry, let's make that there. And the rest we can just simplify. A to the 6 and negative 2 becomes 4 if we add them, and 9 plus negative 8 gives 1. So now let's just work out this, and that gives us 8 over 9, and we've got a4b. We don't need that power of 1 anymore. And making it even nicer, I guess, putting it all under one fraction, a to the 8, a to the 4b over 9. Okay, and so for this example, we're going to do more of the same. We're going to multiply this 3 to everything, okay, even the ones underneath. And then we're going to do the same with this 3. Okay, don't forget we're multiplying because we're powers of powers. Okay, and so once we've expanded everything here, you can see that we've got a fraction divided by something else. And straight away, I don't like this. So I want to change this sign here to a times. Okay, I want to change, rather than division, to a times and flip it. Because right now what we've got here is we've got all this divided by 1. And so if we're dividing by another fraction, I might just flip that so we can have a multiplication. And that makes it a whole lot easier for us to work with. So here we've got times 1 over all of that. And then we can just multiply this here together, which just becomes 8a9b6. And here underneath, if we just use index law 1, we've got a6, b0, c9. And now we can simplify because b to the 0 is essentially just 1, so that disappears because it's 1 times everything underneath. And because we have a9 divided by a6, we make the top part a3. So this here will lead to this. So working with a negative base, the power of negative a to the power of n can be written as this, which also equals to this. So if n is even, okay, well then basically we end up with positive 1. If n is odd, then we end up with negative 1. So let's just see what that means. If I was to say negative 2 to the power of 4, well, we're going to get 16. If I said, that's for an even power, but if I said negative 2 to the power of 3, well, then we're going to get negative 8. And if you think about it, that will always make sense for odd and even powers. So hence, if a is a positive number, then this will happen when n is even. And if a is a positive number, then this will happen when n is odd. So let's just formalize this. Here we have negative 5 to the power of 2. We know that that's going to give us a positive number, okay, because negative 5 times negative 5 gives us 25. Now, because this is an odd power, we're going to get a negative answer. Now, because this is an even power, we're going to get a positive answer. And because this is an odd power, we're going to get a negative answer. Okay, so let's use that to help us simplify each of the following last 3 examples. What is negative 3, or what is just in general, 3 to the power of 4? Okay, we know that that's 81, and because the power is positive, we're going to have a positive answer. Because the power is even, we're going to have a positive answer. Here we have an odd power, so we should get a negative answer. So this will give us negative 125, a to the power of 3. Now here, let's just multiply the 3 with to the power of the negative 2, and the 3 to the power of a. So negative 2 to the power of 3, because it's an odd number, will give us a negative answer. And a to the power of 3 just stays the same. But if I do a little step in between here, this would be negative 2 to the power of 3 and a to the power of 3. And then we simplify that by just simply multiplying out these numbers and multiplying out these bases. So we should get negative 24, a to the power of 5. So make sure you go back and you look at the questions you need to do. For this lesson, it is exercise 13A, questions 1 to 4, 6, 7, and 10AB. Good luck.